Hello and welcome back. In the previous video we looked at a Cobb-Douglas utility function and we were interested to maximize that utility function subject to a budget constraint. In this video we will consider a slightly more complicated utility function which corresponds to perfect complements, and as you know this is represented as a min function. So the consumer is interested to maximize min of x1 x2 subject to this budget constraint where p1 is equal to 5, p2 is equal to 7 and m is equal to 100. Now we have used solver to show that x1 equal to x2 equal to 8.33 is the solution to this problem. What we will do is we will graphically show that we will graphically plot out the L-shaped indifference curve that corresponds to this utility function. As before, we choose a blank chart area and we first plot out the budget line, as you can see here. Now in order to plot the indifference curve, we will opt between two different methods. Method 1 is to split the indifference curve into two parts. The first part corresponds to the series where x is greater than or equal to 8.33. You should be able to verify that y must be equal to 8.33 for any value of x greater than or equal to 8.33 so that the utility is equal to 8.33. The same logic applies for the second part of the series where y is greater than or equal to 8.33, for which x must be equal to 8.33. So that's what we have written here, and method 1 involves basically plotting out this utility function or the indifference curve as two different series. Okay, so we say select chart, select data, add 1 x greater than or equal to 8.33 and y is equal to 8.33. Alright, now you can see here that you get the first part of the indifference curve, which is this gray line. The same logic applies and we now plot out the second part of the curve where y is greater than or equal to 8.33 and x is equal to 8.33. Now you get this L-shaped curve. You can clearly see here that the two different parts of the same curve is represented as two different colors. Now that is the case because Excel has identified this as two different series. Alternatively, we could plot x and y as one series. For that, what we would do is we will just copy and paste this part of the curve below this part of the curve, and we will now plot out x and y as one series. So what do? We just say select data and we add x values and y values. Right, so we now get one indifference curve plot for the entire series of x and y. The only caveat here is, if you notice, this part of the curve is slightly thick. The reason is because if you magnify or if you blow up this curve, you will find that there is some kind of a jump. Now that is the only reason why I would prefer to plot out the L-shaped curve using method 1, where we split the indifference curve into two different components. I leave it to you to choose between the two. Thank you for watching this video.